All right, one more looking at the equivalent capacitance. This one we don't have any potentials or charge or anything like that. I just want you to kind of work through it and make sure that you've got some good practice with it. Try it on your own first, but hey, once you've done that, you can either skip to the end, make sure you got the right answer, or you can just kind of watch the video and follow along the process. Now, the first thing that I'm going to do here is I got to put those two parallels together. The C1 and the C2 are in parallel, followed by the C3, right? Because whatever current we have going here, the current flows through, and then it's got to choose whether it's going to go through C1 or through C2. So that parallel is first. Now, remember, when they're in parallel, the total capacitance is equal to just those two capacitance added together. So C1 plus C2. So this now becomes essentially a single capacitor that has the capacitance of C1 and C2, because all the charge, those two are going to have the same potential difference, and the charge is going to store up on both of those. And so we're going to end up getting more capacitance because the battery is going to be able to charge both of them to the fullest extent. Now we need to combine that C with the C3. Now, because they're now in series, then we're going to use the other formula, which is 1 over the total capacitance is equal to 1 over the capacitance of 1 plus 2 plus 1 over the capacitance of 3. Now, you do need to solve for CT. You can't just leave it this way. So I'm going to go ahead and we're going to go through the mathematics. We'll go 1 over CT. We need to find a common denominator, so it'll be C3 over C3 times C1 plus C2, just multiplied by the denominator C3 over C3. The second one I need to multiply by C1 plus C2 over C1 plus C2, so that'll be C1 plus C2 over C3 times C1 plus C2. And then I should be able to add those together. And so I get 1 over CT. You can't really flip this until you have a single fraction here. That's why I'm putting them together, right? Otherwise, it just becomes really nasty and messy. So I'm going to go ahead and put them together. So I should have C3 plus C1 plus C2 all over the common denominator of C3 times C1 plus C2. And then now that I have one fraction on each side, I can go ahead and flip them both. So I get that the total capacitance is C3, C1 plus C2 over, and I'm just going to go ahead and rearrange them, C1 plus C2 plus C3. That wasn't that bad, was it? Hopefully this is what you got, and let's move along to another example.